Good morning. Today we will going to discuss CRT display devices. In this session we are covering the various monitors, the types of monitor, and in which we are giving the more emphasis on CRT displays, means cathode ray tube displays devices. So, I am Shivani Sharma and lecturer in Electronics and Communication Engineering Department at Government Polytechnic College, Khuni Majra. So, in this session the contents of this discussion is, first we will cover the introduction to the graphics system and then the monitors. In the monitors we will discuss the various performance characteristics and the types of monitors, and third portion which we will cover obviously that is the CRT. In the CRT we will discuss the various components of CRT, the various deflection mechanisms used in the CRT display devices, and with that their performance characteristics, their various scanning techniques, after that merits and demerits of CRT display devices, and what are the future scope of the CRT display devices. So, these are the brief overview of the discussion. So, first I would like to give you the overview of various graphics system, in which monitor displays the video and graphics information generated by the computer through the video card, and monitors are very similar to the television screen, but usually display information at a much higher resolution. Means when we are talking about computer monitors and television screen, both are seem to be same, but there is a difference lies at the resolution level, and further there are many more differences which are lying over there. So, a monitor or a display which is also called as a screen or visual display unit, that is VDU, is an electronic visual display for the computers, and monitor comprises the display devices, their associated circuitry, an enclosure box obviously, and the display device in modern monitor is typically a thin film transistor liquid crystal display, that is TFT LCDs, thin panel, while older monitors use CRT as a deep as a screen size. Means in this we are just saying that in the older versions of monitors we are generally using CRT, that is cathode ray tube, but nowadays the monitors which are coming, that is TFT LCD screens. So, originally computer monitors were used for data processing, and while the television receivers were used for the entertainment. From the 1980 onwards, the scenario is totally changed. Now, the computers have been used for both data processing and the entertainment, while the television have implemented some computer functionality. So, the common aspect ratio of the televisions and then the computer monitors has also changed from 4:3 to 16:9. That is the aspect ratio which we will discuss as a performance characteristics of the monitor. So, up till now we are generally saying that the monitors are used to display the useful information, which can be any graphic, which can be any video, by using the video card, and a monitor with comprises of a display unit, it is called visual display unit. So, in the overview of graphics systems, video display devices, we have video display devices, then input devices, we have various scanning systems just like raster scanning system, graphics software, associated graphics softwares which is embedded in a chip, and CRT monitors, then random scan displays, color CRT monitors, it can be flat panel displays. So, now we will discuss the measurement of performance of the monitor. What are the various characteristics of the monitor? First is the luminance, second is the aspect ratio, third is viewable image size, and fourth one is the display resolution. So, first we will take up luminance. Luminance is measured in candelas per square meter, and aspect ratio, it is the ratio of horizontal length to the vertical length of the monitor, and general aspect ratios can be 4:3, it can be 4:4, it can be 16:10, or it can be 16:9. Means the aspect ratio is generally defining the size of the monitor. Next is the viewable image size, which is generally measured diagonally, but actual width and heights are more informative since they are not affected by the aspect ratio, and CRT, the viewable size is typically you can say it is around 25 millimeter, which is very small. And third is the display resolution. Display resolution is, we can define as a number of distinct pixels in each dimension that can be displayed. The maximum resolution is limited by the dot pitch. Means when we are talking about the display resolution, in the display resolution we are generally talking about the pixels, which is defining the dimension or the size of the dimension which can be displayed. So, the next performance characteristic is dot pitch, then refresh rate and response time. Dot pitch, it is the distance between the subpixels of the same color in millimeter. In general, the smaller the dot pitch, the sharper the picture will appear. Means when we are talking about the dot pitch, we are taking the distance between the subpixels of the same color, and the size is very small, which we can say in the terms of millimeter. Smaller the dot pitch means we are having more and more sharper image on the monitor. Then next is the refresh rate. Refresh rate is defined as the number of times in a second that a display is illuminated. Maximum refresh rate is limited by the response time. And the next feature is response time, is the time of a pixel in a monitor takes to go from active to inactive. Means active means white and inactive is black, and back to active again and again, and measured in milliseconds. Lower the number means faster the transition, and therefore fewer visible image artifacts. Next characteristic is contrast ratio. Contrast ratio is the ratio of luminosity of brightest color, that is white, to that of the darkest color, which is the black. Means we can say ratio of brightness of the luminosity of the brightest color to the darkest color, that is the a monitor is capable of producing. Next is the power consumption, which is measured in terms of watts. Then delta E, the color accuracy is generally measured in delta E. The lower the delta E, more accurate is the color representation. A delta E of below 1 is imperceptible to the human eye. So, delta E's of 2 to 4 are considered to be good, and it requires a sensitive eye to spot the differences. Next is the viewing angle. Viewing angle is the maximum angle at which images on the monitor can be viewed without excessive degradation to the image, and it is measured in terms of degree, which is measured in terms of horizontally as well as at vertical direction. So, next is the display size. For any rectangular section on a round tube, the diagonal measurement is also the diameter of the tube. Means if we are considering a round tube, and in that we are taking a rectangular section, and the diagonal of that rectangular sectional is considered to be as the diameter of the tube, and the size of display is usually by the monitor manufacturers. It is given by the monitor manufacturers and it is given in terms of diagonal, that is the distance between the opposite screen corners. It is the term which is defining how we measure the display size. The display size is measured in terms of the diagonal size of the diagonal, length of the diagonal, that is the distance between the two opposite corners. As we can see in the diagram, we have a round section tube in which we have a rectangular section and the distance of two opposite screen corners is gives the diagonal, or you can say display size. Next is the power saving. Most of the modern monitors will switch to a power saving mode if there is no video input signal received, and this allows modern operating systems to turn off a monitor after a specified time of inactivity, and this also extends the monitor service life. Means nowadays in the monitors we are having power saving option, means if after some time if we are not receiving any kind of video signal, it will automatically turn off, and when it turns off during that duration we are saving the battery life. Okay? So, it extends this life of the monitor also, service life of the monitor also, and besides this some monitors will also switch themselves off after a specific time period on the standby mode. So, these are the various features which we also want to incorporate in modern monitors. So, most of the modern laptops provide a method of screen dimming also after a specific periods of inactivity or when battery is in use. So, this extends the battery life and reduces the wear. And integrated accessories. So, many monitors have other accessories also integrated. This places standard ports within easy reach and eliminates the need of another separate hub, cameras, microphones or set of speakers. So, these monitors have advanced microprocessors which contain codec information, window interfaces, interface drivers and other small softwares which helps in the proper functioning of the monitors. So, means nowadays the monitors which are coming, in that monitors we have some integrated accessories also. We have various standard ports like USB ports, we have ports for camera, hub, for microphones and for the speakers, which is giving a more enhanced facilities to have modern to operate modern applications. And besides this we have many window interfaces and very small programs which helps, means for these all kind of these functions we have some small programs which are embedded in that for the proper functioning. Now, glossy display. Some displays, especially newer LCD monitors, replaces the traditional anti-glare matte finish with a glossy one. This increases the color saturation and the sharpness, but the reflections from light and windows are visible. So, anti-reflecting coatings are sometimes applied to them to reduce the reflections, although they are certainly at the room for the improvement. So, nowadays we are also using glossy displays as compared to the traditional anti-glare matte finish displays. Now, 3D, that is stereo displays. Newer monitors are also able to display a different image for each eye, and often with the help of special glasses we can it gives the different perception of the depth. Means we have also nowadays we are having the monitors which are also giving 3D displays. So, now we will discuss the general basic types of the monitors. First is the monochrome monitor. In the monochrome monitor only one electron gun is used. Means at the diagram if we see, we have heating filament and cathode which is representing one electron gun, and from this cathode electrons are emitted, and after the focusing we have various anodes, we have various mechanisms of anode in which we have focusing anode, we have accelerating anode. When the electrons are emitted from the cathode, we have control grid which is used to avoid the spreading of the electron beam, and when the electron beam is passed through focusing anode and accelerating anode, then it will strike on the screen. So, this is the general monochrome monitor in which we are using only one electron gun, and these monitors are giving just black and white color. Then we have color monitors. In the color monitors we have 3 electron guns, as in the diagram we have red, green and blue color signal electron beams. These 3 electron guns, again they are emitting the 3 electron beams. After the assembly of anodes, that is focusing anode and accelerating anodes, these beams strike on the screen, phosphorus screen, and between that we also having shadow mask through which these electron beams are passed through, which we will discuss later on. So, in general way we can say that in color monitors we are just having 3 electron guns as compared to monochrome monitor in which we are having only 1 electron gun, and with the combination of these 3 electron guns we can have many colors, formation of many colors on the screen. So, the general monitors are CRT monitors which are look like in this way, okay, which produces the output in soft copy, in the soft form. This is the internal view of CRT. In the internal view of CRT we can see that we have a board on which we have various chips which is used to control the various deflection system and cathode, the emission of electrons from the cathode, and further these are on these boards we have various chips which are used to focus the electron beam, right, and at the front end we have CRT screen. Then we will discuss the introduction to the CRT. I am giving the introduction to the CRT. CRT is a vacuum tube which is containing an electron gun. It can be 1, it can be 3, and a fluorescent screen which is used to view the images, and we have some means to accelerate and reflect the electrons on the fluorescent screen and create the images on the screen. So, an image may be represented as an electrical waveform, or it can be a picture, or it can be a radar target, it can be anything. So, CRT may also have been used as in memory devices, and CRT uses a vacuated glass envelope which is very large and deep, fairly very heavy also, and it is very fragile. So, as a matter of safety, it is made up of thick glass, lead glass, so that highly shatter resistant, and it blocks almost all the X-rays emission, particularly if the CRT is used in a consumer product. Means as a disadvantage we can say in the CRT monitor sometimes we have some X-rays emission also. So, to avoid or to absorb these radiation we are generally use CRTs which is made up of thick lead glass. Then the various components of the CRT. In the CRT we have 3 electron guns which is red, green and blue. Then electron beams, we have focusing coils, we have deflection coils. Then in deflection coils we can have vertical deflection system, we can have horizontal deflection system. Then anode connection, then we have a mask for separating the beams for red, green and blue, and we have a phosphorus layer. In the phosphorus layer we have various red, green and blue zones. then we can say we have an enclosure box in which all these components are enclosed. So, then the deflection system, as we discussed, we have electron gun which is a cathode in which we are using some filament. When we heat this filament, electrons are emitted and it passes through the control grid. After that, we have anode section in which we have focusing anode, we have accelerating anodes which are just used to make the beam which are used to just avoid the spreading of the electron beam, and after that this electron beam pass through the deflection system, and the deflection system can be electrostatic deflection system, it can be magnetic deflection system. In the deflection system we have vertical deflection plates and we have horizontal deflection plates. When we applying some voltage to these deflection plates, the electron beam is moved horizontally or in vertical direction on the phosphorus coated screen. Then we can have electrostatic, we can also have magnetic deflection system. By using the magnetic deflection system, again we can move the electron beam in horizontal or in an vertical direction by using the magnetic deflection coils. So, we will discuss the working of the deflection system. The electron gun emits a beam of electrons which are focused to a point on screen of phosphorus, and the beam is positioned on the screen by a deflection system which operates in horizontal and in vertical direction, and the intensity of electron beam is controlled by the intensity signal on control grid. When the phosphorus is hit by an electron beam, it absorbs energy and jumps to higher quantum energy level. As it returns to its normal level, it emits the visible light which is called phosphorescence. In the phosphorus used in graphics display, the persistence of phosphorescence is typically around 10 to 60 microseconds. And before human visual system, it can see a transient image and it must be continually redrawn for some time and refreshed at a higher rate. That is, it should be very higher in critical fusion frequency for the human visual display system. And to allow human visual system to see a continuously refreshed image without any flicker, the refreshing rate has to be at least 60 chips per second. And to allow continuous refreshing of an image, there must be some stored representation of the image from which it can be refreshed again and again, and the image is redrawn on the monitor. So, this representation nowadays is invariably the values of intensity per color at each discrete set of the point laid on a rectangular array covering on the screen. While it may also see that this is a disadvantage to continually refresh the image, and there is a need of representation of the refreshing circles cycles when there is a requirement of animation. So, some very important advantages of such refresh type systems. For example, it is possible to edit an image by changing the stored representation between the refresh cycles for what it appears to be instantaneous updating of the image. Means when we are for the refreshing system, we are just storing the image and we can put some kind of editing also. The stored image, in the stored image we can make some changes which appears to be some instantaneous. So, as compared with the earlier in which the only way is to carry it out and edit was to clear the whole screen and then we redraw the whole image. So, it is a sort of advantage, but disadvantage is that again and again and continually for a specific time we have to refresh the image again and again. So, in the oscilloscopes also we are using CRT. So, in the oscilloscopes CRT we use electrostatic deflection system rather than magnetic deflection system. Magnetic deflection system is generally used in television and large CRTs. The beam is deflected horizontally by applying electric field between the pairs of plate to its left and right, and vertically by applying electric field to the plates above and below. So, oscilloscope which is using electrostatic deflection rather than magnetic deflection, because the inductive reactance of magnetic coils would limit the frequency response of the instrument. Further, this oscilloscope CRTs, the main concentration is the accuracy. We want the accuracy, and if we are using the magnetic deflection, we have inductive reactance of the coil, which would limit the response, frequency response of the instrument. So, it is very important to note that in oscilloscope CRT we use electrostatic deflection, whereas in general televisions and other CRTs instrument we use electrostatic deflection system. Now, we will discuss in case of color monitors, we have 3 electron guns and we have anode assembly, we have deflection system. Besides this, in the color monitors we have shadow mask. Shadow mask, it is a mask in which we have various holes, and through these holes at a time a specific color of beam can pass through, and when it strike on the phosphorus screen, it forms some kind of image. So, color monitors, color tubes have different phosphorus screens which emit red, green, blue light respectively, and they are packed in strips, right, and it forms some kind of cluster which is called triads. So, in color CRTs we have 3 electron guns, each one is of for primary color and arranged in a straight line, or it can be in equilateral triangular configuration, and a grill or mask is used which absorbs the electrons that would otherwise hit the wrong phosphorus. The purpose is that the red beam only strike on red zone of the phosphorus screen, and we want to mask other colors. So, for that purpose we use the mask which absorbs the electrons that is of the other color, and shadow mask tube uses metal plate with tiny holes and placed so that electron beam only illuminates the correct phosphorus on the face of the tube, and another type of color CRT uses a aperture grill to achieve the same result. Then there are certain terms which are related with the CRT displays, that is the phosphorus persistence. The phosphorus persistence is we made where we need to measure or display application the brightness, color and persistence of the illumination. It depends on the phosphorus used in the CRT screen. Phosphorus are available with persistence ranging from less than 1 microsecond to several seconds, and for visual observation of brief transient events, a long persistence of phosphorus may be desirable. Means when we are talking about the persistence, that is the persistence of the illumination of the phosphorus. When electrons are strike on phosphorus screen, as we had discussed, then it imparts some energy, these electrons will impart some energy to the phosphorus atoms, it will jump to higher quantum level, and when it come back to their normal state, they will emit some kind of visible light that is visible on the screen. So, the persistence is how long that illumination is there, and it defines as a phosphorus persistence. Then is the microchannel plate, when this is related when we are displaying fast one shot events. The electron gun must be deflect very quickly with very few electron impinging on the screen, leading to a faint or invisible image on the display. So, oscilloscope CRT is designed for very fast signals can give very brighter display by passing the electron gun through a micro channel plate just before it reaches the screen, and through the phenomena of secondary emission this plates multiplies the number of electrons reaching the phosphorus screen and